Hey there, everybody. Thank you for joining us today. My name is Shane. I run the events over at 10 Capital Network, and we have a great presentation from Dave Vick of Mythic today on trends in AI and edge computing. So we're really excited to have him, and we'll have a couple pitches today as well from Alkanza and Morbot. So stick around for that. If you do have any questions, put those in our chat box, and we'll get to them if we can. I'm going to unlock our chat box right now. And then after each of our pitches later today, we will have a poll. So go ahead and put your interest in the poll if you have any as well. So with that, I'm going to bring up our CEO, Hall Martin, to get things moving.
Great. Thanks, Shane. I want to thank everybody for joining us today. We have a great topic here. We hear all the time these days about AI and also edge computing, and having both in the same application can be quite compelling for investors as well as new applications. So with that, I'd like to bring up Dave Vick and have Dave introduce himself and kick into his presentation there. Looking forward to your questions in the chat box. We'll have some time for that. Then we'll have a presentation from Michael Hendricks on Alkanza, and then Jun Yi on Morbot that uses AI technologies in their application as well. So Dave, if you go ahead and turn on your video and put your slides up, let's go ahead and let's start by having you introduce yourself and Mythic, what you guys are all about, and we'll kick into it from there.
Thank you. Glad to be here, and keeping a fairly tight presentation. I feel like we could talk for hours about this subject that's so expansive. Let's see, so Mythic is a edge AI inference company, meaning that we focus on how AI is deployed at the edge. And it was founded by, sorry, I have a bit of a cold, but the company was founded by myself and Mike Henry out of the University of Michigan, Ann Arbor. And we're currently headquartered in Austin, Texas, with teams in Silicon Valley and Vancouver. The technology that we're using to get ahead of the NVIDIAs of the world is analog compute and memory. And we have a complete stack for that, starting with a PCI Express cards, M.2 form factor, and moving all the way through the software stack to help you deploy your models at the edge. So today we can deploy 30 frames per second, full HD computer vision at 5 watts or less. And we have a great roadmap to large language models, signal processing, and sensor fusion. So when we talk about the edge, there's actually a lot of different definitions of the edge that I've seen out there. And typically when Mythic is thinking about the edge, we're thinking about how do we deploy AI directly at the sensors that you're trying to process with. So as opposed to, I don't know if you've used like a Nest Cam or similar, where you have a camera system and it sends a highly compressed video up to the cloud, and then there's some cloud post-processing to recognize whether or not there's a package at the door, et cetera. That tends to not work very well in general, but then also there's a wide variety of situations where that doesn't work in general. And I'm going to talk a little bit more about that in a bit, but the general idea is that cloud is very slow, it's expensive, and it can be unreliable for high performance applications. And because of the complexity of neural networks and the amount of compute requirements that there are, you haven't really seen edge AI deployed to the same extent as we have in the cloud. So today you can see ChatGPT is making huge waves, and other large language models. And these models take enormous systems. They're servers that take up multiple U's of space in the server rack that can cost $500,000 to run, thousands of watts of power. And this is not something you can put in a consumer device, especially if you're constrained by power and volume as well. And so these are the different areas that we're seeing a lot more interest today, and a lot of focus on how can we improve edge AI in these spaces. So there's navigation where you have devices that are moving around on their own, and these can be large like vehicles, and very small like drones and small robots, like it's going to be shown today at Morbot. There's a ton of focus in the industrial space, particularly on inspection of materials in factories and other aspects of tracking how efficient the workplace is. So there can be tracking of particularly human performance. So can we figure out if the way we're deploying our human resources is being efficient on the floor. There's health and safety. So these are your security cameras. They're your health devices looking for cancer and other anomalies. AR VR is a big space that's been talked about for a while, like the metaverse. You're starting to see Apple just deployed a great AR system that's really kind of changing how we think about AR and VR. And these applications require extremely low latency, which can be challenging and obviously impossible for cloud. RF and sensor processing, there's a wide variety of signal processing that's done today. You can see this is like a LiDAR system trying to scan the environment around it. And then obviously just intelligent systems. So can you talk to your, I don't want to name the devices, but the ones that you talk to get answers from, can they be smarter and more effective in your day-to-day life? And so a lot of these holdbacks today stem around the limited performance that is available in edge AI systems. And typically, if you're looking at a consumer device, you can't spend a huge amount of money or power. And so you end up limiting the resolution that you're running at. And so if you look at, this is a object detector. So in object detection, you're looking for objects and labeling them, like vehicles here, people walking their bikes. And you're trying to label these. And if you run it at a lower resolution, in this case 640 by 640, you end up missing many objects that are in the distance, especially ones that are smaller as well. And so this is taking the same network, increasing the resolution from 640 by 640 to full HD, 1408 by 1408. And now all of a sudden you can see a lot more objects in the distance. And you can also start seeing smaller objects like these handbags. They're up close. And so as new compute technologies become available and neural networks become more efficiently designed, you're going to see a lot more applications that can actually utilize this type of AI technology directly in the system. One thing that isn't obvious at first for edge AI is the latency requirement. A lot of times when we look at edge compute, we're looking at frames per second, our inferences per second. Can I do 15,000 inferences per second of ResNet 50, for instance? And a lot of times that's not really that important because you might only have one camera that you're trying to process in parallel. And so if you think about, I have a camera, let's say I have a vehicle and I'm moving down the road and it's traveling at 60 miles per hour. That means every millisecond of latency that it takes to go from the camera sensor output to recognizing the different objects in the road, that is about an inch of distance that's been traveled in that millisecond. So if you have to wait, say like 100 milliseconds and you've traveled multiple feet at that point. And so the question is, how can I make it so that I can make a decision as quickly as possible and make my system as safe as possible? In robotics, for instance, there's a lot of different types of sorting machines, especially with, like, for instance, produce. And in each of these machines, there's going to be a camera system that's scanning the objects, and then a bunch of actuators that kind of push those objects into different belts or into different bins. And the decision latency that you have there can limit the throughput the systems can operate at. And so again, this is a situation where milliseconds of latency make a huge difference for performance. And then human interaction, as you see with this is sort of I found this online and I didn't think it was real, but if you're using an AR VR headset, any sort of latency above about 10 milliseconds can cause nausea. And obviously, if you can have that latency be even lower, it's going to make it much more comfortable for the user to work with. And so in all of these cases, as you try to increase the resolution of the images that you're working with, or increase the complexity of the neural network that you're working with, it gets hard to meet these latency requirements. And so it becomes very important that we have new compute technologies to help lighten that load. Power consumption is another big space for edge AI. And so this is not something that's obvious to the system, especially when you consider devices that are plugged into the wall. And so obviously, if you're working with a battery or a solar cell, keeping your power below a certain level becomes increasingly important. But we have some customers that use, for instance, PoE switches. And you'd think that since you're plugged into the wall at that point, it doesn't matter how much power that you draw. There's two different limitations that, or a couple different limitations that they run into. One is that these switches have limited power delivery themselves. So in one case, the customer needs to actually have more switches than they had ports, so they couldn't fully utilize each switch because each of these ports can only deliver so much power to the device that they're delivering to. So for instance, this whole system here might be able to deliver only 150 watts. And so if you're using more than 20 watts of power, then you can't deliver to 8 different cameras in parallel. And then the other part is that the heat dissipation becomes a big challenge, especially for small devices. So if you look at this camera system here, this is a Google Nest. The heat dissipation has to be entirely through the surface of this device. And so it has an aluminum enclosure that's going to radiate heat, but that has only a limited amount of heat that it can radiate off. And obviously you don't want to get up to 100 Celsius on the surface, or you're going to end up burning your customers. And so many of these devices end up with complicated and expensive and large heat sinks in order to dissipate all that heat. And so if you can reduce your power consumption, then you can reduce the size of the device itself. And so as these new compute technologies come online, we can start reducing the size of the system and the cost of the system beyond just the power itself, also the cost of the enclosure and the full system cost. And so then obviously what's been in the news recently has been ChatGPT and all of the large language models. And so a view of what that might look like at the edge was demonstrated by Google. They have a great robotics lab, and they wrote a paper recently about how they were using large language models inside of the robotics. And so the idea is you have a computer vision model or a set of computer vision models that can take an image of the environment and turn it into a description. So this ends up being maybe a few paragraphs of description of what's in the environment. And then the large language model can ingest that description along with some commands about what you'd like the model to accomplish. So go pick up the red ball or something along those lines. And so the large language model can then build this sequence of actions after that. So normally when we think about language models and we think about, like, for instance, ChatGPT, it's more of a conversational interface, but you can develop these models so that the output looks more like a series of instructions. And obviously that is performed quite frequently in systems like VS Code with Copilot. So Microsoft GitHub's model where it can generate computer code. Since these large language models are very good at generating computer code, that means they're very good at generating sequences of actions, and they can be fairly complex. So the other night I was working with one of these models, and it gave me a whole example for creating an optimization suite for a problem I was working on. And so when you can give it a description of the environment and you can give it a task, that large language model can give you a series of very precise actions written in an API. And it can also ask questions. So the output can also be further queries back to the computer vision models, asking it more about that environment and get some more details. And so what Google was envisioning here is that you can start combining more of these models together, these computer vision models and these large language models. And we've seen some of our customers do that as well, where they have multiple models that they're working with, not a large language model because those are too big for edge devices today, but they'll be working with multiple models that are being coordinated by some sort of central decision maker. And large language models are exciting here because they're very good at planning and creating a set of processes or a set of steps to work from. And I think today there's a lot of interest in incorporating these into these systems because they are so flexible. So I can't express how many times I've asked my Google Home to cancel a timer, and it hears me correctly, but instead stops playing the music that I'm playing or something along those lines. And it's just that today's interfaces that we're working with are just so inflexible because they have to be hard coded. And adding in these language models gives the flexibility of going from a high-level description to a variety of actions without needing to hand code each of those in place. So the question is, how do we get something like a large language model into an edge system? And as I mentioned, these models take thousands of watts and cost hundreds of thousands of dollars to execute. And so we need a huge jump in compute technology in order to make that happen. And what Mythic is using is analog compute. And the idea of analog compute is, can we compress information into a fewer number of transistors and a few number of wires? And we have some concrete examples here where we're looking at 8-bit digital multiplies versus 8-bit analog multiplies. And so looking at like storing an 8-bit weight, you have to use many transistors to store any 8-bit integer. And a typical single-bit storage in a system would be an 8T, so an 8-transistor SRAM cell. And if you need to store 8 of these for an 8-bit number, then you have 64 SRAM transistors. And going to analog compute, you can actually use just 4 flash transistors, so 2 by 2 transistors. And the reason why you need 4 of these is because you're going to store a positive value and a negative value separately, kind of side by side. This is called differential signaling. And you can store an analog value in either of those directions, and you can compress it into just those 4 transistors and store 256 levels on just those 4 transistors. For input signaling in this, when you do an 8-bit multiply, you'll need 8 input wires for your input signal. So you're going to have these 8 inputs multiplied by the 8 weights. Whereas in analog compute, you can use a single wire that has a voltage signal. And so again, this is where you can have 256 voltages on the wire instead of 8 wires, each with 2 voltages. The output signal can be going from 16 wires down to 2 wires. This is a differential current signal. And then the multiplication is the biggest one, where we can go from thousands of transistors for an 8-bit multiplier down to the same 4 flash transistors that we used up here. And so what happens is you're going from hundreds or thousands of transistors down to a few. And you're going from maybe dozens of wires down to a handful. And when you can reduce the number of transistors in the wires by orders of magnitude like this, then you've reduced your costs because there's fewer things to move, or there's fewer things to build. You have lower latency because you don't need to travel as far. If you think about, if I have a small town versus a big city, it takes longer to travel around the big city. And then there's less power consumption because there's fewer devices moving around. There's less capacitance being charged and discharged. And so we can reduce the amount of power being drawn dramatically. So this is a very high level description of how this works. It's being shown signal ended instead of differential, like mentioned before. But the idea is that we have this grid of flash transistors that are each acting as a tunable resistor. And the weights are implemented as conductance, whereas conductance is 1 over R. And our current equation, if you think about V equals IR, if you use conductance instead, it's your current is going to be equal to your conductance times your voltage. And so now when we put in our, we program each of these conductances to be proportional to the weight that we want to represent. We apply a voltage that's proportional to the input value that we want to represent. And then we get a proportional current down this vertical wire for each of these neurons. And what happens is that the addition that's occurring here is for free. And so we've got multiplication through the flash transistors and then free addition. And the output is going to be converted from current into a digital value. Now, the great thing about this is the density is huge. So each of these blocks here, I'm showing a 3 by 3 grid. We actually do 1024 by 1024 in these enormous arrays. And so we can actually store 80 million weights on each chip quickly and efficiently. And we're able to store 8-bit values in each one of these conductances. When we access this bank, it's going to turn on 20 million cells for the entire chip. So we've got 256,000 cells per bank or per array, and then 20 million cells turned on simultaneously for the whole chip. And then we don't actually read any of these values. So there's no, when you think about doing a matrix multiply in digital, you have to get the weights from memory, bring them to the multiplier. You have to get the input data from memory, get it to the multiplier, you multiply that stuff and you take it away. And in this case, we don't need to do any of that. We're just going to read, we don't read the array, we just perform the calculation directly in the array. So bringing this all together, we have this very small device. It's actually, this is a M.2 card here mounted underneath a, this is Orange Pi 5. It's very small. Actually have one, I don't know how well you can see it, but it's a pretty small system. We've got the M.2 card underneath. And this is a standard size for hard drive, for the SSDs. So we can run this under 5 watts for full HD computer vision, single frame latency. So you don't have to wait to queue up 8 frames and then process them in parallel. And then the cost is obviously very low because it is a very small chip, very dense computing. We have a great roadmap. So today, what I'm showing here is Gen 1. And Gen 2 we're going to have available, or is in development now. It's going to be available in 1 to 2 years. And we're getting a big jump in energy efficiency and cost by about 4x because this is a new technology. And then Gen 3, we're continuing that trend with some heterogeneous integration, which is another presentation. Don't have time to talk about that today. But kind of bringing it back to, and this is my last slide, but bringing it back to that problem that we showed earlier. So how can we put a 7 billion parameter large language model in analog compute? And this is a rough mock-up where we include every single parameter in analog compute and using no DRAM at all. And that might not be the exact best way to do this, but I just wanted to show how far we can take it. And so in this case, we can fit 7 billion parameters in this sort of chip grid array. This is something that we've looked at before, where we have interfaces on the edges of our chip, and we're able to network them together into this huge neural sheet. And we can run all of this model with the entire neural network resident in memory under 100 watts. And we can reduce the cost by more than a factor of 10 compared to running on these servers. And so it's very exciting in analog computing, very exciting to see what's happening with large language models and the expanding horizons of edge computer vision.
Great, Dave. We have some questions for you. The first one is, what about noise, especially noise as a function of temperature? What's the impact there?
Yeah, so noise is definitely something that occurs in analog compute, just both for the computations as well as the weights. And we strive to keep the noise below the quantization error. But something to consider in these systems is that when you're working with the real world, there's always going to be variation in the environment. So you have your camera I'm in the camera right now. If you look closely, there's going to be a little bit of pixel noise. And the pixel noise that your camera has is going to be greater than the noise that is in the analog compute. And this is seen even further when you consider changes in the environment. So if I turn on or off different lights in the background, that's going to change the input to the neural network more than there is noise in the analog compute. So you wouldn't want to use analog compute to run Excel. But for problems where you're working with signal processing, which already has the concept of noise built in, it's not a problem. In fact, it could be a big benefit because the AI training process deals with so much of that noise in the first place that it's more robust to it when you deploy it in the real world.
Next question is, if we are curious about the heterogeneous integration, where can we go to learn more?
That's a good question. You might be able to Google the term. That's referring specifically to chiplets and 3D stacking. TSMC in particular has some great examples about 3D stacking, or wafer level processing, I think they call it. And I don't have any specific links, but there should be some good examples out there.
I had one more question. What's the cost differential between analog computing and digital computing?
We've reduced for the same level of performance, we reduced the cost by about a factor of 10 in Gen 2. I think we're about a factor of 2 right now in Gen 1. And so and then we're expecting that to grow over time because digital compute's been so heavily optimized over the days, over the last multiple decades that it's really fine-tuned the cost side. Analog compute's very new, so we have some big jumps coming in future generations.
Is there a difference in cyber activity between analog and digital computing? Is one easier to hack than the other?
That's a good question. We saw, I haven't seen this recently, but a number of years back, there was a lot of interest in the research community about how you can take a exact image. You can take any image and then apply noise to it in a way that causes a classifier to miscategorize the image as maybe it's like a picture of a salt and pepper shaker, and you apply some tweaks to the pixels that a human can't see, and then suddenly the system thinks it's a orangutan or something ridiculous. And because we have that analog noise in the system, you can't precisely construct individual pixels like that. Now, I don't know that would be a real problem in the real world. Normally, you can't have pixel level attacks on something that has a camera input, but for something like cyber warfare, something where you've got a precise digital input, that might be a little more applicable.
Great. Well, thanks. Those are the current questions we have now. If anybody in the audience has more questions, go ahead and put them in the chat box. And Dave, if you monitor that during the second half of our hour here, we'll invite you to give some feedback to them if you can. And then, of course, we can follow up afterwards as well. Thanks so much, Dave, for the great presentation. And with that, let's move to our first presenter, Michael Hendricks of Alkanza. Michael, if you can go ahead and launch your slides. Love to hear more about Alkanza and what you guys are doing there.
All right, thank you very much. Hopefully everybody can hear me.
Yes, we can, and we can see it.
Awesome. I am Michael Hendricks, founder and CEO of Alkanza, and we're making immigration simplified. Make sure I can click through these here. All right, so there's a major problem. If you put a bunch of people into a room and you ask them to describe immigration in a couple words, people who aren't involved are going to talk about congressional inaction, maybe border wall, maybe DACA. People who file for a living would say the complexities, the difficulties, the delays, the cost, the lack of language access. People who need the process would probably look more at the attorney cost, attorney delays, attorney difficulties, complexities. They can't agree on what the one problem is, but they can all agree that it is a major problem. So in steps Alkanza, we are a vertical SaaS play with artificial intelligence platform that assists immigrants directly and their attorneys in applying for immigration benefits. Very similar so that people can understand it, very similar how TurboTax simplified taxes. We have simplified the immigration process, but where we're different is that we have a whole large language model AI that is working to assist, and we'll talk a little bit more about that in a minute. The way it works is for D2C, it's actually B to smaller b to C. It works with find your eligibility, fill your process, and then print and submit. So file, find, fill, and file. We also have lateral B2B full service, where somebody could throw up their shingle, for instance. A single solo attorney doesn't want to hire a bunch of legal assistants, and they send the case directly to Alkanza. Alkanza processes it and sends it back for them to process with their client, get signatures. And we also have a subscription-based enterprise model. Now, what gives us a competitive advantage is, as we were just listening, the AI. So the large language model, we're currently using a commercially licensed Llama 2 product that we are building and fine-tuning. The difference is that as you see in the major language models that are around, the generative systems that are responsive online, I won't name names either, but those systems that are available that everybody's chattering about, they have a very large data pool. So they have this corpus that's unwieldy. And sometimes when you put too much information into a system that's looking at probabilities, it's determining vectors and probabilities that may not exist. For instance, how does an AI determine relative truth? One person can have a lot of data and information saying this is truth. Another person has a lot of data and information and saying this is truth. And the AI has to determine which one of those is true. And it just can't do that yet. So what we've done is we've created a system where we use AI to procure data, AI and then experts like me to procure data. And then we put it into the operations assistant and we allow the AI to start fine tuning. We get training and fine tuning through a responsive model. And then there's human intervention, taking that responsive model, refining it, putting it back into a proprietary corpus and redoing that epoch over and over and over again until you get a very high level of confidence. For instance, most of these systems right now with large data pools have a 52, 53, maybe a 60 if they're lucky % confidence rate, what means when there's accurate information coming out. We are closer to an 80% and we're only on epoch number 10. So we also provide our AI is named Leo, Legal Efficiency Operator. Leo is growing, is learning, provides improvements to B2B. For instance, an attorney can have great efficiencies, currently could work about 500 cases with our Leo system in their B2B enterprise system. They could run easily 1,000 cases with the same team. Usually an expert attorney could bring in 1 to 1.5 million in immigration, whereas we could triple that. Double to triple, and currently a staff member of 1 attorney and 3 assistants can run 500 cases. If you didn't want to increase your cases, you just wanted to make more money, then you could reduce your current staffing by a couple legal assistants and save throughout the year. For our D2C improvements, we have currently, there is no easy to use information center online. There are information centers, but they're not easy to use and they're not AI based. They're systems like Emma under USCIS. You can ask her questions, but she's really just looking at a database and giving you information correlative, where our AI is actually using vector systems. Leo is a free expert attorney trained AI that can be accessed on almost any device in almost any language. That doesn't exist currently. Also currently expert information available only through going to a paid attorney visit and you have loss of time. At this level, the expert attorney level information and will be directly available or is directly available for free on the customer schedule in their own language. And then Leo increases availability of plus time and cost saving of 50 to 60%. So there's a lot of efficiencies built in here in accessibility. So these are slides just talk about the different things that we offer: AI-based digital platform, multilingual website, AI-based affordable services, and attorney reviews for pretty much every filing. We also have document translation, specialized learning suites, and then full suites of English as a second language. For B2B, also the AI digital platform backed by human guides and back office support. Multilingual system, that doesn't exist currently. The systems that exist proprietary only to attorneys are, I think the largest one I've seen only has 5 languages. We have 125. The system decreases the human resource costs and increases efficiencies. And once again, we have attorney reviews that back it and the full other suite of offerings that we give as part of our services. The total market is $10.5 billion per year in the US only. There are a lot of people applying for immigration benefits to the US from abroad. This does not include that number. There are currently over 11 million undocumented people. This is a total market. So this is the TAM, right? Available almost 14 million lawful permanent residents, over 9 million lawful permanent residents currently eligible for citizenship, 500,000 green card approvals per year, 25,000 fiancés, over 500,000 consular processes, 10 million non-immigrant, 2 million labor visas, and a total of 10 billion spent on immigration attorneys every year. Where the beachhead market, we're looking at, actually, we've gotten over to where we're at 200 customers served to date. D2C, what we're looking for primarily is under 25, some high school education, around $40,000 a year. Out of the whole market, 2.5 million per year are applying at that level that meet that criteria. That's 1.2 billion per year. In the B2B market, primary targets are small immigration firms, less than 10 people, annual revenue of anywhere of $1 million, $500,000 to $1 million, or new entrants into the market. There are about 3,500 offices that meet that criteria, which break down to about 21 million per year. So our model actually is based on leveraging a small b, a local agent. So there are local people that are operating in the gray space, meaning that what they do is legal, but how they do it is not legal. So they're non-licensed immigration application providers. They're called notarios. So there are over 20,000 of those in the country. Primarily, we're looking to bring those people in. And so they're no longer operating in the gray, they're operating in the white. And actually, we're onboarding 24 today, our first group of 24. And each one of those have anywhere between 3 and 5 people that they want to bring with them after they verify that the system works as we say it does. So easily reach that 100-person goal by EOY 23, which turns in, if you look to predictions, this is the big one, Alkanza local guides totaling at 100, they total about $500,000 per month. And that's just the tip of the iceberg. Also, I've become one of the top legal influencers on immigration. The returns on that, as you can see, digital marketing and social marketing, also 5-time return is what we're predicting. International influencers, moving the bar internationally to bring people in. And we're looking at great returns on that, especially as it grows with affiliate programs set up. 30 law firms by the end of the year using the system, which would increase our income as well. And then future government contracts by around 2026. And we're looking at those, and I know it's a little cut off, but I will say that based on our information and what we've been able to determine, there are agencies providing similar processes for other government. There are corporations providing similar processes and services for other government agencies, and their contracts are anywhere between $500 million to $800 million. And based on USCIS alone, their current budget, $500 million would not be an unanticipated contract with them. And they don't have anybody else to turn to, and the delays are getting worse. Right now, we're at 44 months for a waiver of unlawful presence. 44 months. That's 3 years and 8 months just to get forgiven for having come in unlawfully and stayed unlawfully, even when you don't have any criminal activity. So there are various product lines. They all fall in the same vertical, just so that we're very clear. This is a deep and high vertical that allows us to saturate the specific market. So we have the fiance, family, victims, employer-based, non-immigrants, document translations. The vault I haven't spoken to yet. I'll speak to it in a minute. Of course, we have the B2B enterprise systems, and then affiliates like educational visas. That's really come in when we're talking about having people internationally. Now, the Vault is a subscription-based D2C product where the person will only maintain and house data for a couple of months after the person has used our system, and then that data will be taken out, will be completely disregarded, will completely deleted permanently in order to keep us from ever having any security issues with people's data. If they purchase the Vault, they will be able to do on a subscription month to month. They'll purchase the Vault, and it'll allow them to house that data for a very low cost, about $10 a month, at-rest encryption. So it's very, very, very difficult to get in there, requires specific codes to get in, but it allows it to be protected for them for the future. Our financials are following right along what we've projected. Actual revenue is, if you can see the red line underneath, that's because it's following directly on the projected. And I believe that by the end of this year, we will be closer. We will see a very large tick up and be closer to the ideals by the end of December. We have a couple people that operate in the space, but they're not direct competitors because they don't have any AI and they're no live fill and file. So in other words, it takes 5 to 6 weeks turnaround minimum for them to get your information and to give you back your packet, whereas ours is a DIY with guides in the backside. So the AI will operate eventually. It's not there yet, but as we train it, we'll get it there in about 3 or 4 months, where it'll be operating as a personal expert attorney that stands over your shoulder and watches what you're doing and corrects you as you go, so that by the time you get done, there'll be a 90 to 95% confidence rate. And then it's not just generative. So it's not just giving you information and responses. We're training it to give probabilities and determinism. So it should be deterministic of what your likelihood of approval is. This shows a few of the different competitors and what benefits they do have, but nothing like what Alkanza is providing, especially on the tech side. We do have some exit strategies. Obviously, places like Intuit, TurboTax is very similar. It's an admin-based system, form filling. So they could easily take over and they would have reason to. Lidos is the one I was talking about, already has a contract to do the filing with the IRS, where they process filings for taxes every year, over 100 million. And they would easily be able to move over. We could also talk about going public, but I believe that's a little premature. So the current ask, well, this is the team. Of course, I'm the founder, CEO, years of experience in immigration law, expert. I've got an MBA as well, have already exited, small exit for, previously. fractional COO, and our trainer guide, Lily, she's been working with me for 10 years in immigration. Robbie is in sales, fractional CTO, 20 years of experience for Nathan there, some advisors, and then some fractional people that we have contracted for web creation, implementation, and marketing. So the ask, we're currently at a $4 million pre-money valuation on a safe note. We're looking to raise $1 million. This is a seed round that will be used for various things, continuing the AI and software development, marketing strategy and implementation, which we have a lot of that built in already. So it's really more implementation. Our native app, which no one else has, will be available coming here in about 2 months in Q4. Multilingual translation development, the AI will actually begin to translate the documents for us, continued software development, SaaS integration, and affiliate program refinement. Any questions?
Great. Thanks, Michael. Dave, I invite you to come up and ask any questions you may have. My question for you, Michael, is what exactly is AI doing for you in this application?
Okay, so there's a lot of data that's available. The problem is there's no way to refine it. So AI is having two major parts in this. Number one, it's providing information that is simplified down and boiled down to a usable nugget to where you don't have to go search for it online. There's no other system that's doing that. Number two, it's providing a guide. So what it's going to be doing is watching as you fill out your application. And then as you fill it out and you do something wrong, for instance, hey, you were supposed to put 5 years worth of addresses and you only have 3. And also you can't have any gaps. So right here, you have a 2-month gap. If you were unemployed at that time, make sure you put unemployed. That way your application is as complete and accurate as possible, even before it goes to the human guide that then checks over it again. So there's a lot of benefits the AI is giving here.
Great, thanks. Dave, what's your question?
So once you've proven that this works really well, what's your moat to prevent it from being copied?
So the problem is that you'd have to have a lot of different pieces in one place at once, and it's very difficult. So you'd have to have a tech expert that understands not only stack systems, because this isn't a web app. This is a system that's built on a platform that's a whole nother conversation about the platform that it's built on. But it's very flexible. It's not the hard code that's required in a lot of places. Number two, you'd have to have the expert that comes in on AI that understands how AI works, and then also how to connect that LLM. First of all, refine the data, which means you need an expert immigration processor and an attorney. But then you'd also have to understand how to put that into your system so it begins to have a feedback loop with your system and begin to learn how the process works. And then lastly, you have to be able to acquire new customers. And with ours being the first one in the market, the only one, it'd be very difficult to replicate. But more importantly, we're the ones accessing the market directly at the go-to market level for local guides.
Great. Thanks, guys. That's the end of the time we have now. Thanks, Michael, for a great presentation. Thanks, Dave, for your question. And with that, let's bring up Jun Yi of Morbot. Jun, if you could launch your slides and kick off when you're ready.
My name is Jun Yi. I'm the co-founder of Morbot. And Morbot, we're trying to build fast and intuitive robot with better human-robot interaction. Today, there are still a lot of challenges to build great robots. So in our opinion, robot has to deliver several key aspects in order to be a good product. The first thing is we believe robot has to be fast. If you look at the robots out there today, there are only a couple cases people are so excited about, and they're all kind of related to the speed. For example, the Boston Dynamic robot can do a backflip. The electric vehicle can run 100 miles per hour autonomously. So it seems the speed is crucial to deliver a good performance robot. But speed is also an issue, right? So it requires instant computing bandwidth. It can be a power incentive. So that's why in this area, we're very interested in analog computing, as Dave and team is developing. We think that could be a game changer for robotics. Another aspect, as we focus on human-robot interaction, we believe today's robot needs to mimic human decision making a little bit better in order to get more acceptance. So the human decision making is a very complex process. We're not only having this logic thinking, we also have instinct part of it and also reflect part of it. And to mimic all that is, bring the computing requirement even higher, because this is all very low latency response. So I think there are a lot of things are missing today to build a great robot. So as a team, we recently, switch our gear and try to develop virtual robots. And we think the technology readiness today can build a very good virtual robots versus physical robots. The reason being that, today you see a lot of tools coming out of the market in the last couple of years based on generative AI. Things like, Stable Diffusion, Midjourney, DID, those kind of applications. People can use these tools to manipulate photos, videos, voice much easily, right? So as a result, this generative AI actually bring the people's expectation in the virtual world much higher than the physical world, or the virtual world actually progressing a lot faster than the physical world. So if our goal as a company is trying to build robots that are fast and intuitive, it probably makes sense for us to build a digital human first, or virtual robot first. As a team, we actually developed our own, customer service chatbot using Llama, and just by simple training of this robot, we can definitely see the benefit of it, right? So this virtual bots can put up the right information about a product much faster and better than any of my staff. So not only we can train the customer service or the product detail into this robot, we can also train some sales skills and also, even the brand core value into this robot. So we can have a very good content trained by the large language model. And then on top of it, if we build a, presentation through a real-time animated digital character to deliver that content, we can result a very interesting virtual sales assistant, and we believe there are a lot of benefit to that. And this is the virtual sales assistant that's going to look like. And this is a 3D display with generative AI supported real-time animation. You actually require a lot of computing power to animate this kind of character in real time. And basically the content is supported by large language model with all the interactive content. And then we can adjust the culture, when it's deployed in the United States versus in Europe, the digital character can be quite different. And the front camera can understand the customer's, emotion, for example, and can adjust the digital character behavior in real time. And this actually require quite a computing power as well. Oops, sorry. So there are a lot of benefit of the virtual assistant robots. So for example, the improved service, the fast deployment of information across many locations, and we can digitize the customer interaction and do a fast iteration improvement on that. And also, the skills, as mentioned by Michael, multilingual, for example, and we can also train this virtual bot with a sign language, which very few people know how to do. And also online, offline experience, and more importantly, customize brand, ambassador. For example, we can let Elon Musk to sell Tesla himself, right, as a digital character. In terms of value, we believe, for a mid-sized store, deploying this virtual assistant, inside the store, we can create probably on average maybe 5 headcounts value, and that can translate into $20,000 per store. If you scale that to a large retail chain like Best Buy, that can be $140 million per year and about 10% of their net profit. So we believe we're trying to, we can create a huge value by delivering a virtual sales assistant robots. So as a company in the past, we've been doing physical robots, and we're currently at about 1.5 million sales revenue annually. And moving forward, we believe that the opportunity for us to build a fast and intuitive robots is in the virtual robots. So in the next period of time, we're going to dedicate ourselves to build virtual robots. And the application can include a lot of, can cover a lot of area like sales assistants, education, and sign language interpreter, for example. And then maybe in the future, we can, when the technology readiness, it's getting better and more ready, we can, switch back to physical humanoids as we originally planned. As a company, we are focused on software. So by licensing the robot character and also the SaaS features and the service income, so we should be a majority a software income company. As a team, we have a very good team. I'm from a technical background. I co-founded a semiconductor company before and sold to Microchip. Richard is on the business side. He has actually helped to create Roku, a very well known in the US. He knows the retail space very well. Neon is our AI lead. He was the former CTO of Newegg, so he's helping to build this Llama and all that for us. And Carl is our CTO. He knows the consumer space very well, and also have Pei-Yuen as a co-founder and Leon and Terry as a advisor. And that's it. Any questions? I want to leave more time for questions.
Sure, Dave. What's your first question?
For the retail space, what would be the easiest, I guess, first impact that you think you could make? Is it answering questions about the products, or is it greeting people, or is it working the cash register? Where would you begin?
It's a combination of all that. For greeting people, for example, if we project a virtual human into the window, facing the street, we can get more customer into the store, right? And inside the store, if we deploy all the screens and people can interact and talk to them, can ask the real-time information like discounts, detail of the product information. For example, if you go to the Nike stores, there's so many shoes, and very few of their own staff can understand the difference between all different models, right? But those digital, robots can understand, those details much better, actually. So those are the key value we can present to them, and also for certain shops, for example, they have online their membership, so we can do online and offline experience. To make sure they feel they're VIP customers in the stores. There's a lot of things we can deliver, with this.
Great. My question is, what capabilities does analog computing enable in your application, Jun?
Yes, so we are doing this virtual, sales assistant using the 3D rigged characters. It's actually require a lot of computing power to deform in real time. Especially with low latency, as Dave mentioned several times. This low latency actually require a lot of computing power behind it. So once, we definitely wanted to have, some kind of analog computing technology behind this, so we're going to achieve fast and low power computing to support this digital human out there. Yeah.
Great. Dave, what's your next question?
What is the process for training one of these systems do you expect? Would you kind of upload all of the customers' data sheets or product specs into the system? Or I'm trying to imagine, like, how would a customer engage in one of these virtual assistants?
Right. So for us, currently, we just upload our data sheet, FAQ forms. We actually can, upload our just raw supporting emails as well to train those boards. And again, this is more of a post-sales, and then we can train this bot to have, sales tactics, sales skills, and also the brand value. Those are require a little bit more work to prepare the training data. Yeah.
Okay, so you start with like maybe you have like a few strong foundational models for different types of roles, and then the
Right.
it's like hiring a salesperson. You want to get a really experienced salesperson in there, and then the details are just that sprinkled on top.
Exactly. Yeah.
And what's the go-to-market strategy with that particular application? What channels will you be using?
So our first group is definitely we're trying to do this with brick and mortar stores, and we particularly feel the first engagement we have is probably more toward a tourism centric area where people need multilingual supports, those kind of things. So that that will clearly bring value to the store. So this will be the first wave of the engagement that we can have. Yeah.
What kind of price point are you thinking you'll get for that?
Well, for us, again, if we create, so for if we create a value equal to one, they hire one additional staff. Usually, the store can pay at least 40 to 50% of that cost to us. So that's can be significant.
Rev share agreement. Okay, great. Dave, we have time for one final question. What might that be?
For the virtual assistant, it seems like the physical interface would be helpful for the brick and mortar store, but often they have a website as well. Do you see that same interface being available on the web?
Right, that's a good question. So for the brick and mortar stores, we tend to use a very the 3D character with very fine details. So that's where require a lot of edge computing to deliver that. But for online, then probably it's going to be a cloud based. So we probably not going to support a very detailed 3D animation on it. But they definitely can see this character with lower resolution on their website. Yeah. So.
Yeah, bring back Clippy or something along those lines. It might be easier to render.
Yeah, sure, definitely. Yeah.
Okay, great. Well, I think that's it. The end of our time here. Any closing thoughts there, June?
I'm a longtime supporter of analog computing. I definitely want to see Dave to succeed. And I definitely think this is probably one technology can revolutionize the entire edge computing. Yeah. So.
Great. And Dave, any closing thoughts from your side?
That was all great stuff. I love the robots and the future virtual world that we'll be working in. And thank you for having me, and glad to be here today.
Right. Well, appreciate Dave. Thanks so much for a great presentation. Thank you, June, for yours as well. And Michael, also a great presentation. Thank you guys in the audience. You asked some great questions there. We'll record this and send it out afterwards for those who want to go further in it. And we're glad to make connections with any of these people that you would find interesting. Just let us know in the follow-up email or on the chat box, and we'll go from there. With that, we'll go ahead and close it out for today. We're at the end of our time, but appreciate you guys taking time to share that with us. And we'll see you guys next time. Have a good one.
Thank you.
Yeah.